Hey guys, today we are going to solve this problem. Its rating is still 1800. So as always, we are going to start with the example here. So the first number here is the number of cases we are going to have. So in this case, we are going to have 3 cases, right? And this is the number of the following array. There are going to be 11 numbers here. And each of the number indicates a kind of icon here. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 icon number 1, right? And we have 1, 2, 3, 3 icon 5. So we have 2 kinds of icon. One is number 1 and one is number 5, right? Actually, we have 4 number 5 here, right? So what we are going to do is that we are going to find a screen to put this icon in the screen, right? So in this case, we can have a 2 screens, right? The first screen, we can put 4 icons of number 5, right? Because in one screen, we can only put one kind of icon. And we can put 4 icons in the first screen. And there is a feature of this screen. So um, the maximal icons we can put in a screen is S. And this S is what we can decide, right? We can choose a S for our screens. And all of the screens must have the same S. And in one screen, there is 2 restrictions. The first restriction is that there must be either S number of icons in a screen, or there can be S minus 1 number of icons in one screen. So in this case, if we have more 5 here, we need to either put 3 5s in a extra screen, or we can put 4 5s in a screen, right? That's the first restriction. We must put either S or S minus 1 number of icons in a screen. And the second restriction is that the icons in one screen must be the same. So we either put 4 number 5 here, or we can put 4 number 1 here. We cannot put 1 and 5 in one screen, right? So the answer we are looking for is the minimal number of screens we can have to um, put all of those icons in the screen. So in this case, the first answer is 3, right? We can have 3 screens. So how can we decide the S here? So we must choose the best S, right? The best S means it must be as big as possible. So here we put 4, 4 5s in a screen, right? And then for the second screen, we can put 4 1s. And then in the third screen, we can put um, 3 1s, right? Both of these screens satisfy these 2 constraints. So we are good here. So 3 is the minimum number of screens that we can have. And what about uh, 5? If we set the s as 5, then we still can put 4 5s in the first screen, right? And we can put 4 ones in the second screen. But in the third screen, we only have 3 ones. So it's less than 5 minus 1, right? So if we set s as 5, we cannot find the uh, final answer. So that is not possible. So the same reason applies for s equals 3, right? Because um, if we put 3 um, fives in the first screen, then for the second we only have 1 5. That's not what we want, right? And if we put 2 5s in the first screen, and we are going to have 2 5s in the second screen. So that is uh, satisfy the constrictions here. But in this case, we have 2 screens. But in this case, we only have 1 screen for 5, right? So this obviously is better choice. So the final answer is 3 screens. So how are we going to solve this problem? Uh, let's wipe the board, and we're going to have a new have the example here. So how do we solve this problem? So we have several guidelines. The first guideline is that we need to find a S that is as big as possible, because S is the number of icons we can put in a screen. If we can put more icons in one screen, that means less screen in total, right? So this guy should be as big as possible, right? And um, the second guideline is that if we choose a bigger S, that means this S is not necessarily satisfy our constrictions, right? Because if we choose a certain S, we must make sure that for each screen, there are either S or S minus 1 number of icons in it. And we need to make sure all of the icons are the same, right? But that's not necessary be true for each S. So how do we solve this problem? The simple answer is brute force, right? We can just brute forcefully iterate all of those S from the we are going to have a for loop. Sorry about that. We're going to have a for loop for the S from max to 2, right? In the worst case, we are going to have a S equal to 2. In that case, we can have each screen has either one icon or two icons, right? So if any of the S satisfy this condition here, then we are going to choose that S for the answer. And we are going to calculate the final number of screens based on the chosen S, right? So how do we decide if a S can satisfy these conditions? So that should be pretty simple, right? Because in this case, we are going to make sure that S is satisfied for 1, 2, 3, 4, 5, 6, 7, 7 ones, right? So we only need to make sure S is good for 7 number of items. And also we need to make sure that S is good for 1, 2, 3, 4, 4 number of items, right? So if S satisfy both of these cases, we can choose S here. So how do we make sure that S can satisfy 7 items? So we only need to check if S mod, actually 7 mod S equals 0. If the remainder is 0, that means that we can even input uh, the all of the items in the screens, right? And each of the screen will have S items. And what if the remainder is not equal to 0? In this case, we are going to put the first we are going to have 7 divide S number of I mean S plus 1 number of screens, right? Because um, 1 second. So if this value is not to equal to 0, that means if we put if we have this number of screens, right? We and each of this screen have S icons. There are some more icons we cannot put them in the screen, and so in this case we are going to have one more screen, and let's say if all of these screens have S um, number of icons, uh, we are going to have more icons than 7, right? So in that case, we need to remove some of the icons. And we need each of the screen, in each of the screen, we can remove at most one icon. So in that case, how many icons do we want to remove? So that is this guy minus 7, right? We want to remove this number of icons. And how many screens do we have now? So we have 7 divided S. We have this number of screens. So if this number is bigger or equal to this number, that means we can remove enough number of items so that the number of items we have is equal to 7. So this is a condition where we can have a valid s, right? And if either of the conditions is satisfied, we can say that this S is good for this number of items. And we are going to do the same for this number as well, right? And if both of these numbers are good, then we are going to use this S. Let's take an example here. So if we choose 4 as the S here, then um, 7 mod 4 doesn't equal to 0. Then we need to check if 7 minus 4 plus 1. This is the number of screens we are going to have for 7 items. That is 2 screens. We are going to have 2 screens. And each of the screen are going to have S items, which is 4 items. And now we are going to have 8 items in total. So 8 items is 1 item more than our target number of items. So we are going to remove 1 item. So how many screens do we have again? So we have 2 screens. So at most we can remove we can remove 2 items. So that is bigger than 1 item. So the 4 is a good S here, right? So that's good. So we can use this as and calculate the final answer here. The final answer is how many screens do we need to have. So we just need to add the number of screens to our final answer, and that's it. So let's take a look at the code here. So we have a little bit of trick when we implement the algorithm. So one of the trick is that when we read all these icons, we are going to keep the counter in a map, right? So this guy here means that um, A, I, J, I mean, AI equals J here means that um, this kind of icon, the we have J number of icon, right? In this case, A1 equals 7, right? We have 7 ones, right? And the B here is the B I here is the for those kind of icons who has 7 instance. We have J number of those icons, right? In this case, we only have one have have 7 number of items. So B7 equals to 1, right? And for 5, we have A5 equals 4. So for 4, we also have one kind of these items because we don't care which kind of items is it. We only care that how many instance does this kind of icon has, right? So for those kind of icons have 4 instance, there is only one such icon. So the answer is 1 here. So in this way, um, we can continue to iterate the S here. So this is where we start the loop of S. And this is the maximal possible value. And this is a minimal. And here is where we check if current S satisfy the constrictions here. So this is the first condition where we can be sure that S is valid, right? If J mod S equals to 0, right? This case. And this is the second condition, right? And if one of the condition is true, then we can continue to check other kind of icons, right? And if all of one of them is false, then we need to break out and choose another S, right? If all of them are true, then we can choose the current S and print out the answer here. So the answer again is the number of screens we are going to have, right? So I guess that's it. That is today's problem. Hope it helps. Thank you for watching.